Okay, this is lesson 23, number properties. Okay, we're going to go into a lesson about the different rules in mathematics. We call these rules properties. And we need to be able to know what they are and identify them because we want to abide by the rules in more than just automatic way like, oh, this is just what we do because this is what I've seen, okay? So just like, let's say you had two students that were doing a math problem. Both really thought they got the right answer, but both answers were, but only one of them was correct, okay? How do you know which one did it correctly? Well, one student have seen other people do math problems, and they just did the math problem because they've seen other people do it, and they just copied the other people's steps, and they think they did it right because that's what they observed. The other student who got it correct actually followed the rules and saw that followed the different types of properties that are available, okay, and is able to identify them. Who would you trust more? The person who has seen other people do it and did the problem, or would you trust the person who knows the rules and did the problem correctly? First or second person? Second person, right? Okay. Or another idea, here's another way to compare it. Let's say you've been to a football game. Have you been to a football game before and you know all the rules, and then your friend came with you and they're like, oh my gosh, we just lost 15 yards. What's up with that? And they're all getting angry, okay? All right. Why is that person getting angry for? What? They don't understand the rules, right? And you're like, well, they lost 15 yards because the ref was like, called them for this, for a penalty, right? Or what if you were a ref? Would you want a ref that didn't know the rules, was reffing incorrectly? No, that would be horrible. It would depend if you were winning, right? Right? If you liked your team, right? Okay. Anyways, so I'm going to go through these properties. If you're on the video, you'll need to pause them as we go. Okay, so here we go. The first set of properties these are all properties of equality. So if you're on the video, you should write these down and I'll explain them. So properties of equality, these all have to do with like thinking of a seesaw. So there's 4 operations in math. There's add, subtract, multiply, and divide. So whatever you do to one side of the equation affects the other side of the equation equally, okay? Just like, let's say we had 2 kids on a seesaw. Okay, y'all know what a seesaw is? Yes. Yep. Okay, so if you have kids on a seesaw, they both weigh the same weight. They both are they're just both the same weight. Doesn't matter what size they are, they're just the same weight. Will the seesaw balance? Yeah, of course, okay. What we say about the addition property of equality is, this first property is that if I added 10 pounds to this student here, I'm going to have to add 10 pounds to the other student. Right? Will the seesaw balance out? Yeah, good. Subtraction property of equality is the same thing. We're just saying, like, let's say I take back the 10 pounds from one side, I'm going to have to take the 10 pounds back from the other side. Will the seesaw balance? Yeah. Multiplication property of equality is, let's just say that we had, I wanted to double the amount of students on each side. Same way, I'm going to double the amount of students on one side. I'm going to have to double the amount of students on the other side. Make sense? Will the seesaw become equal? Yes or no? If I double the students, same weight, same kinds of students? Yeah, of course. Let's say I took the students off and I put a sack of potatoes, 20 potatoes on each side, same size, same weight, okay? Will the seesaw balance? Yeah, of course. Now what if I divide the potatoes, 20 potatoes, by 5 on each side? How many potatoes are left on each side? 4. Will the seesaw balance? Yes, because they're the same size potatoes, okay? Makes sense? Okay, so turn to your neighbor. One's tell twos about the first 2 properties, 2 tell the ones about the second 2 properties. Ready, set, go. Next one. Okay, next one is this thing called the inverse property of addition. Let's say can I use you, Matthew, as an example? Okay, let's say I give Matthew $5. How much money does Matthew have? $5. Okay, what happens if I take away $5 from Matthew? How much money does he have now? $0, right? So 5 and -5 are inverses. They're opposite. They cancel each other out. They become 0. Does that make sense? Yes or no? Yes. Okay, good. Okay, what's the inverse of +5? What's the inverse of -5? What's the inverse of 100? Good, okay, good. Then there's this identity property of addition. Let's say Hayden here. Can I use you as an example? Okay, Hayden is, his identity is Hayden, okay? What if I give Hayden $0? No. Does it change who he is as a person? No. Right? His identity stays the same. So if I add 0 to Hayden, does he change? No. What if I gave Hayden $1 million? Does his identity change? Yeah, it does. All of a sudden, everyone wants to be your friend. Right now, I'm just playing. They all want to be your friend anyways, of course. So the identity property, right? We add 0 to something, it doesn't change, okay? Then there's the inverse property of multiplication here. This one is a little bit more technical. It's when we have a fraction multiplied by the reciprocal, it's always going to be equal to 1, okay? Fraction multiplied by the reciprocal is equal to 1, okay? Turn to your neighbor, explain the inverse property of multiplication really quickly. Ready, set, go. This right here, the one that's flashing. So what happens when you multiply a fraction by the reciprocal? What's the answer? 1, good, okay? Then we have the identity property of multiplication. We'll go back to Hayden. What happens if I multiply Hayden by 1? How many Haydens do I have? 1. Does his identity change? No, okay? So if I multiply any number by 1, I get the same identity, same number. Good. Okay, then we got commutative property of addition. I need 4 people up here. Let's have 1, 2, 3, 4. Come on up. 4 students, come on up. Don't be in any rush, you know. Yeah, you too. Okay, get in any order you like. Okay, so I got, okay, look up here. I got 1 student plus another student plus another student plus another student. How many students do I have? 4 students, good, okay. Pretend like you're driving and get into a different order. Pretend like you're driving around. Don't wait. Okay, you're all driving, right? Okay, they're all in a different order, right? 1 student plus 1 student plus 1 student plus 1 student equals? Did it change my outcome? No, okay. Why did I make him drive? Well, because of when people go to work, they commute to work, commutative property. They change the order, they move around. Commuting means to move around. Did y'all get that? Okay, so that's why I had you all drive. Okay, so now drive home back to your seats, okay? Good. Okay, so commutative property is when we move things around. Continuing on here. Associative property. Oh, I need 3 guys now. Okay, you 2 and Hayden. Okay, come on up. Okay, Hayden's hanging out here by himself. These 2 guys are hanging out over there by the computer cart. Okay, these 2 guys are friends. So we got two students plus this 1 student. How many students? 3, right? They associate with each other. They're friends, right? But let's say one day Dalton's all like, hey, I'm out of here. I don't like hanging out with your purple shorts. So he walks over here.
It's okay, Josh.
Josh's like, whatever, I'm cool by myself. I don't need you. So now Dalton is hanging out with Hayden, and he associates with him, right? And he's like, oh, we're friends now. So what's 1 student plus 2 students? 3. Does that change the answer at all when I change the association? No. Associative property. Good, thank you. Sit down. Okay, that works the same with commutative property of multiplication, except it's multiplication. Last thing is distributive property here at the bottom. So when you distribute the same amount to everyone. So let's say I had a big sack of potatoes. Big sack of potatoes, and I wanted to give you each 3 of them. I would have to multiply all of you, 35 students, times 3 potatoes. So I give 3, 3, 3, 3, 3. It's a multiplication type of property. Does that make sense? Okay, good. So all we're doing is you have to know these properties in the back of your head. These are like the rules, and when things happen, you have to call out what the rule is. Okay, so here we go. Number 1. Okay, y, you can write these in your notes as you go. Y plus 0 is equal to y. I'm noticing, hey, y plus 0 is equal to y. It's like I'm taking an original number, I'm adding 0. Does it change anything when I add 0? No, it doesn't change the identity. And I'm using the addition sign. So what do you think it is? The addition property. Is it addition property or?
It's addition.
Addition, and what is it? It's not good. It's not changing the identity of it. So it's the identity property of addition. Okay, write that down. Okay, number 2. We got 3 times x plus 2 is equal to 3 times x times 3 times 2, right? Let's say I had 3 potatoes to give to each of these inside students, an x and a 2. Well, I'm going to multiply 3 on each of these, right? So what am I doing? I am distributing, right? Distributive property is what this second one is, okay? Oh, where did the D go? Let me write that back in. Distributive property. Okay, continuing on. Number 3. Okay. Number 3, turn your neighbor. Look at number 3. 4 times 3 is equal to 3 times 4. Okay, go. Describe what property is being used. Look at your notes. You should all be looking at your notes, and this is what you're doing. You're figuring it out, showing your neighbor on your notes which one it could be. And describe why. Okay, turn your neighbor. What is it? What property? Good. Commutative property of multiplication. Good. Next one, number 4. We're running out of time. Shh. We need to finish the lesson. Turn your neighbor. Explain what this one is. What is it, everyone? Good. Associative, right? Can't you see that? These groupings are changing. 7 and 8 are friends, and then 9's on the outside. But then 7's by itself here, and 8 and 9 are grouped again together. You see that? Different associations. Good. Almost done here. 2 more to go. Number 5. Number 5 is like number 3. What do you think it is, everyone? Commutative property multiplication. And then the last one. That'll be the hardest one of the day. What do you think it is?
Inverse.
Turn your neighbor. Explain it to your neighbor. What is it? Okay. Inverse property of multiplication. All right, so you have homework tonight. It's identifying the properties. Bring it tomorrow. This ends the lesson. Have a great day.